We're given an integer array nums, and our goal is to start at index 0, reach to the last index. During the movement, we can make the jump, and we can receive the score. So for example, if I jump from index 0 to index 1, the score I receive is 1 times 1. If I jump from index 0 to the last index, the score is 1 times 3. And it's equal to the current number at index I times the distance. First of all, we can solve this question in brute force approach, and this is going to take 2 to the power of n. At each index I have 2 traces. I can either jump and land, so I jump from 0 and land on index 1, or I can jump over. So at each index we have 2 traces, right? And at total we have n elements. So the total time complexity is 2 to the power of n. And the final result is just we find the maximum score among all the traces we have. We can try to improve from our last brute force approach. I'm going to come up with the top down with Memo, which is going to take n squared time complexity. Starting from index 0, I can either jump to index 1, or index 2, or index 3. And this comes with the decision tree. So from the left hand side, it means the start point. And on the right hand side, this means the land point. And you can see there are repeated calculation. So we can actually cache the decision tree. Once we already calculate the subtree under 2 and 3, and we encounter the same path, we won't have to go into deeper. And this is the Python code for the top down with Memo. For each index, we need to run the for loop, so this is going to take n time. And we have, at total we have n elements. So it's n times n is equal to n squared time complexity. Unfortunately, this is not going to pass the test during the contest. So we need a better solution. We need to improve to the linear time complexity. Next, I'm going to talk about the greedy solution. Suppose we are starting from index 0. We're trying to find the optimum way that somehow we make the jump and we always land on the optimum index such that we receive the max score. So we only land if the destination j such that the value on the j it's greater than our current value. In this case, 3 is greater than 1. So if we jump over the value that's greater than the current value, so for somehow we land over here, the current score we have is 1 times 3. And if we land on the value that's greater than the current value, and we continue the jump, the total score is going to be 1 times 1 plus 3 times 2. So we have the following comparison, and I have this ... notation, meaning that this is happen in the future. So at first we have, we keep the current smaller value and then we continue to make the jump. On the other hand, we land on the greater value and then we continue to make the jump. So it is guaranteed that this representation is smaller than if we land on the greater value. So we prove this by contradiction, such that we need to land if we find a greater value. So this is the Python code. At first, we are starting from the second element. We record the previous I corresponding to the current value, and that means we are starting jump from index 0, because at first we always jump from index 0. So if we found a greater value, then we make the jump, and we accumulate the score in our result. And I need to reassign the current value, because now we are jumping on index 1. Its value has 3, and then I reassign the index. So from here, I continue to make the jump until I find a greater value and land. And in some cases, we can find, for example, over here, we couldn't find the value that's greater than 5. So after the while loop, I need to check if the previous index is on the last element. If it is not, then I need to recalculate. I need to accumulate the result again to the result variable. If you like this channel, please click like and subscribe. Thank you.